Today, let's start looking at straight line graphs. To start with, in a straight line graph, one variable or one quantity is graphed against or versus another quantity. For instance, suppose I had this graph right here, and my vertical axis represents, say, money made, or my profit, money made. And my horizontal axis represents the months. So then suppose my data is contained in this chart right here. And it shows that at 0 months, I made $0. At 1 month, I've made $100. At 2 months, I've made $300. At 4 months, I've made $400. It's 3 months, I've made $400. At 4 months, on the 4th month, I've only made $300. In the 5th month, I made $450. And finally, in the 6th month, I made $500. Now, notice something about this graph. It's not a straight line. If I connected it and made a line graph out of it, I'd have a curve here. It's not a straight line. Straight lines are indicate a direct relationship between the two variables. Let me write that down. So this chart right here would represent the data from a direct variation or a direct relationship. And if I plot that, 1 is up at 200, 2 is up at 250, 3 is at 300, 4 is at 350, 5 is at 400. You see that I get a straight line right here. In fact, I could fill that line in, and you notice we get a straight line. A straight line always indicates a direct relationship or a direct variation between two variables. And those are the kind of lines that we want to deal with today. Now let's look at 3 equations right here and the charts for them, and let's fill out our charts, and then we'll graph them and see which ones look as though they're straight lines. Okay, go ahead and fill these out, and then I'll come back and fill them out myself, or I'll show you what they should have been. So this first one, we're taking 3 times whatever x is. So 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9 and 12. The next one right here, I'm going to plug my 0 in. So I'll have -2 times 0 plus 5, which will be 5. Take my 1 in, -2 times 1, which would be -2 plus 5, will be 3. Take my 2 in here, plug it in, -2 times 2 plus 5 would be 1, and finally my 3, -6 plus 5 equals then -1. So there's my y coordinates for these x coordinates. Likewise on this last one, let's take a look at it, try it, and see what you get. So -2 squared will be +4, -1 squared will be 1, 0 squared 0, and so forth. Now, let's graph each one of these and see which one of these is a straight line. You might already know. So when I plot my points on this first one, 1, 3, oops, let's do this again. And we see that it looks pretty clear that we have straight lines right here. Right there is a straight line. Here's a straight line. And on this graph is not a straight line though, is it? So we're kind of getting this curve, and we're going up like so, and I'm not a very good curve drawer. Not a very good curve drawer. Anyway, so these are linear or straight lines, and this one's not. It turns out to be a quadratic. So these are the ones we'll be concerned about, are straight lines. Now let's examine a characteristic of straight lines. And mainly, that characteristic is slope, or what direction the thing sits at. Every straight line has slope, or our British friends call that gradient slope. And slope is always indicated by the letter M, or usually anyway. And the slope has been agreed that it will be the change of y over the change of x. Now, let's take an example of a straight line, and I'll show you the change of y over the change of x, and that should be pretty obvious to you. So suppose that these are some of the points on the line, 5 coordinates of the line, 1, -2, 2, 1, and so forth. Well, the first equation, or the first question you might ask is, do they fall in a straight line? And you could figure that out by simply plotting them. Go ahead and plot them and see what you get. And it's pretty obvious that you've got a straight line here. It certainly looks that way anyway. We could just quickly put the straight line in there. And it's obvious that, yeah, it's a straight line. Okay, now, how can I determine the slope of this thing? Now, remember that we just said that, or we defined the slope or the gradient as the change of y over the change of x. Well, I can take any situation, like right here, these 2 points. We'll call that a situation. And look at this. From here to here is my change of x, which is 1. And then from here to here is my change of y, which is 3. Same thing happens here. If I go over this far and then up this far, I get, again, 1 out of 3, or 1 to 3. Actually, if you're going the way it's written, change of y over change of x, my gradient here, or my slope, my m, is 3 over 1. Now, another way that you can see that is by actually looking at the chart and looking at the differences. For instance, these differences from consecutive x coordinates are each 1. 3 to 4 is 1, 4 to 5. So there's a constant difference there. And then the differences between the consecutive y coordinates are all what? They're all 3. And whenever you have that relationship between the constant differences, if the x's are a constant difference and then the y's are a constant difference, that indicates that direct variation, or better yet, it indicates a straight line.